Hi everyone. So today we're going to learn about hemoglobin. So we already know what exactly does hemoglobin means, right? Hemoglobin is, if we divide the hemoglobin into two parts, then the first part will be heme, which is actually the non-protein part, which contains the porphyrin ring, and then we have the globin part. The globin part is the protein part, right? So when we look at the structure of hemoglobin, hemoglobin consists of four, polypeptide chain. That means this polypeptide chain is different, this polypeptide chain is different, this is a different, and this is different, right? Before, when we studied the structure of myoglobin, only one structure was there, which was folding into a 3D structure, and then that contained only one polypeptide chain. But out here we have four polypeptide chain that also folded in a tertiary manner and then combined together, right? Now, before looking into this, let us see what different types of chains do we find in hemoglobin. So as you can see over here, that there are two globin family. The first one is the alpha globin family, and the second one is the beta globin family, right? The alpha globin family family consists of two chains. It is alpha and zeta. Okay. Now, when we talk about the beta family consists of beta, gamma, delta, and then we have epsilon. Okay, so together, when we talk about the globin family, together alpha and beta consist of 6 types of chains which could be present in the hemoglobin. Now we're going to learn about these chains and where exactly are they present. So first, let us try to see some details about hemoglobin. So a hemoglobin is a multimeric protein, right? So multimeric means it consists of more than one polypeptide, and if we talk specifically, it is a heteromultimeric. It is a heteromultimeric. Now we're going to learn about it. Why is it called a hetero multimeric? And then the structure of hemoglobin is actually a quaternary structure. That means the peptide bond the polypeptide has already folded in the tertiary structure, and then now it is again coming together, many tertiary folded polypeptides. That means many tertiary folded polypeptides are now coming together as one. That's why it is the quaternary. And then it has four heme prosthetic group. And then when a globin has four heme prosthetic group, it is usual that it is going to carry four oxygen molecules, right? In our previous video, when we learned about myoglobin had only one heme prosthetic group, and then it carried only one oxygen molecule, right? So now let us try to understand the structure of hemoglobin, right? So hemoglobin, as I said, that it is a quaternary structure. That means all these this structure is actually a tertiary structure folded. This structure is also a tertiary structure. This is also a tertiary. This is also a tertiary. That means all these tertiary structures have come together and then they have formed a quaternary structure, right? And then why is it called a multimeric protein? Because it consists of different polypeptides, right? These are different. This is not like from a one single polypeptide. That means it has one N terminal, and then it has another C terminal, and this protein has folded itself like this. And this type of protein, four proteins coming together, this is why it is known as a multimeric protein. Now I told you that it is a heteromultimeric protein. Why did I call it heteromultimeric protein? Because two of the polypeptide is going to be from the same family. As you can see, it's alpha and alpha, right? And then other two will be from different family. That means it is consisting of different families. It is not, if it was like alpha 1, alpha 2, then alpha 3, and then alpha 4, and if all these proteins, together, they belong to the same family, then I would call it like a homo multimeric protein. But it is not in that case. It contains different polypeptide groups, right? And as I said that this each structure will have one heme prosthetic group present in it. Now, if you don't know what exactly is heme prosthetic group, I request you to go back to my video of myoglobin and try to understand what exactly is a heme prosthetic group. Now, a heme prosthetic group, if I just have to tell you like very short, then it contains of an iron, yes, and then it has I'm going to write P pyrrole. So it's an iron will be present in the middle, and then it will be connected to 4 pyrrole rings. This structure will be known as porphyrin ring, and then there is a possibility that the iron will be forming a 5th bond with the globin chain, right? The globin, that is the hemoglobin, and then the 5th one would be with the oxygen, right? So this is actually the heme prosthetic group that I'm talking about, and this is actually a non-protein part. So the protein part is the globin, and the non-protein part is this particular part, that is the heme prosthetic group. Okay, so every tertiary structure which is present in the hemoglobin contains a heme prosthetic group, and then 4 heme prosthetic group are present over here, and then to each heme prosthetic group, this is one heme prosthetic group, right? So with each heme prosthetic group, one oxygen will be attached to the heme prosthetic group. Therefore 4 oxygen molecules will be attached to hemoglobin. Now let us try to see other things. So what is the molecular weight of the hemoglobin? It is 65,450 Dalton, right? And then the alpha chain is made up of 141 amino acids. That is each chain. If I have to like add it up, if I have to like 141 into 2 and then 146 into 2, then approximately I think 574 amino acids will be present in one hemoglobin. Okay. So now let us try to understand what are the variants of hemoglobin. So hemoglobin have 4 variants. The first is the major variant. That means this particular variant is present in adult humans, and then majority of the adult humans will have the hemoglobin of this particular variant. So it contains 2 alpha chains and 2 beta chains. Okay, and then it is called hemoglobin A1. Now the other 2% is actually the minor hemoglobins. That means there are very few people who have this type of hemoglobin variant. That is hemoglobin A2, and then it contains the family, that is alpha 2. It contains 2 globin chains, alpha and then delta, right? Okay, now I hope you're understanding what is this alpha delta. I already discussed over here that there are the family, the globin family over here, right? So all these are actually present in a human being, but in different stages of their life. So we're going to learn about it. So the third one is the HBE, that is the hemoglobin of embryo. Okay, so it contains epsilon, 2 epsilon and then 2 zeta. And then another one is hemoglobin fetus, that is it will have 2 alpha chains and then 2 gamma chains, right? Now the most hemoglobin variant which is very much has a higher affinity, highest affinity towards the oxygen, is this particular one. Okay, and it is around when the embryo is almost more than less than 8 weeks. So this is the hemoglobin variant that will be present. And then this is the one fetus which will be around 3 to 9 months. So this is the hemoglobin. And then these two hemoglobins have the most affinity to oxygen, because we already know that, when a baby is present in the embryonic stage or a fetus stage, it cannot breathe on its own. It has to depend upon its mother for the oxygen uptake. So therefore this is actually the highest, then followed by this one, then followed by this one, and then followed by this one, right? So someone who has a slight genetic change, then this person will be able to bind to oxygen. This person's hemoglobin will be able to bind to oxygen very efficiently. So other things other than that is, now let us try to see how does a hemoglobin structure of a normal adult looks like. So this is the structure of hemoglobin. It has two alpha chain, right, and then two beta chain, right, and then there is a central channel out here, which does not allow this alpha 1 and then this alpha 2 to have interaction with one another. This beta 1 and this beta 2 will also have a very weak interaction between one another, but this alpha 1 and beta 2 will have, this alpha 1, a beta 1, and then beta 2 will have a nice interaction. Similarly with these three as well, right? But then when we talk diagonally, it's gonna have a little bit of weaker interaction. Now this stage is actually known as the deoxygenated stage. That means when oxygen is not bound to hemoglobin, this is the structure that we usually find. But then what happens is, after the oxygen is bound to one of the hemoglobin chain, for example, let us say the beta chain, right? So if oxygen comes and bind to beta chain, then what will happen is there will be a slight conformation chain in the three hemoglobin chains, and then what will happen is it will have a conformational change which will allow the oxygen to now bind to the newly conformated hemoglobin in a very easy manner. That means the first oxygen, when it comes and binds to this B1, it is very hard for this oxygen to bind to this heme prosthetic group. But as the oxygen binds to this group, there will be a conformation change, and all the other three oxygen will now try to bind to the heme prosthetic group in a very easy manner. When there is a rotation of about 15 degree, 15 degree, then what happens is this particular above, this together is known as a protomer. So this protomer will have a slight rotation, not slight, but then it will have a 15 degree rotation. When it has a 15 degree rotation, the B1 comes to this side, and then A1 comes to this side. That means they have exchanged their places, right? And this is actually the oxygenated form of hemoglobin, right? Now as you can see, the deoxygenated state of hemoglobin is known as tensed state or a taut state, TAUT, taut state, and then this one is known as the oxygenated hemoglobin or the relaxed state. Now the reason why a rotation of the the reason why it is very essential for the conformational change of the hemoglobin is actually to allow the oxygen to bind to all the heme prosthetic groups, and then this is the thing. So now when we talk about similarity, when we talk about the similarity in terms of amino acid or in terms of structural similarity, then 18% of amino acids are similar to that of myoglobin. That means the hemoglobin consists of the amino acids similar to myoglobin, but to how much extent? Only 18%. And the conformation, that means the type of conformation, the type of structural conformation that it has, it is almost 80%. That means when we look at myoglobin and hemoglobin, it kind of like looks similar to one another. But when we look at the amino acids, only 18% similarity is present. Now, as I told you about the weak interaction as well, right? So the weak interaction was between the diagonal hemoglobin chain, right? And then what was the another? Structural rearrangement. And this is the structural rearrangement which is necessary for the oxygen to bind to all the other hemoglobin chains. Now, when we talk about hemoglobin, we all know that hemoglobin is a very important uh, molecule which allows to dissolve, sorry, not to dissolve, but like to allow the oxygen to reach to different parts of our body, right? So that is actually the main purpose of hemoglobin. In terms of myoglobin was able to like store the oxygen, but then in terms of hemoglobin, it is very important in the transportation of oxygen. Not only oxygen, but other materials, like sometimes it also transports H plus ions and CO2 ions, which is like the byproduct of the tissue metabolism. So all these things are very important. And then today we learned about the structure of hemoglobin, and how hemoglobin rotation takes place, how many types of variants are present in the hemoglobin, and which is the most which has the most affinity to oxygen, and why is that, right? And then also like the different types of globin chains which are present in the hemoglobin, and then also why is it called a multimeric protein, what is its molecular weight, and then how many amino acids consists of that particular hemoglobin, each alpha and beta chain, right? And then also like how many heme prosthetic group are present, and then how many oxygen will be bound to that particular heme prosthetic group, right? So if you like this video, please like, share and subscribe. Thank you so much for listening.